Math 30-1. Welcome back to our continued travels with Trig. And in the previous lesson, you guys learned a new way of dealing with angles in Trig, and that was radian measure. And we're now just going to go back, and for the most part, we're just going to talk about, well, what do trig ratios look like when you deal with radian measure. Not a whole lot new, a lot that's kind of similar to a lot of things we talked about standard position in Math 20. So we start with Math 10. Our primary trig ratios were sine, which was opposite over hypotenuse. We had cosine was adjacent over hypotenuse, and tangent was over it, and that was SOHCAHTOA. And that's where we didn't really have to worry about standard position. We were just dealing with right angled trig. But now we have some other things to introduce, and that's trig ratios that are called reciprocal trig ratios. And so cosecant is 1 over sine, which, if you're wondering what that looks like in a triangle, well, 1 over sine would be hypotenuse over opposite, and secant is 1 over cosine, which would be hypotenuse over adjacent, and cotangent would be 1 over tangent, which instead of over A would be A over O. We can remember these, that whenever you see a cosecant or secant, those are the reciprocal ratios. The primary reciprocal trig can be given in terms of x, y, and r. So when we deal with standard position, and when we go in standard position and we think of our sides, our opposite side is y, and our adjacent side is x, and our hypotenuse is always r, and r is always positive. And depending on what the quadrant is, which we'll look at in the next example, x and y can be positive or negative. But sine clearly was y over x, and cosine was, whoopsie, not y over x. Sine was y over r, being disagreeable. Y, oh, I want to be like that. Sine is y over r, cosine is x over r, and tangent was y over x. So cosecant, which is the reciprocal of sine, is going to be x over y, and secant is the reciprocal of cosine, so that would be r over x, and cotangent would be x over y. You should memorize. No, you should not. We don't need to memorize these things. We just need to remember basically what we had in Math 10. Because in standard position, I don't want you to memorize stuff. I want you to understand it. We don't need to memorize anything. We just need to know that when we start dealing in standard position, it's based on our reference triangle. And in our reference triangle, we don't talk about opposite and adjacent. We talk about y and x and r. And now it's positive y, positive y and a minus x, and so on. And we're going to look at that in the next slide, okay? So don't memorize stuff. You don't need to. When we look at the next slide, I want to cover up that bottom. You want to complete these quadrants and look and see, well, what do our trig ratios do as I go from quadrants 1, 2, 3, and 4? And remember, when our reference triangles are in different quadrants, we have sides that are different in whether they're positive or negative. So cosine is obviously, and we'll carry on, cosine is obviously x over r, and those are both positive, making it all positive. And tangent is obviously y over x, and those are both positive, and that makes that positive. In fact, everything, all things here are positive. All ratios are positive. But when you go to quadrant 2, right, what do the sides look like? If you have an angle that's somewhere past 90 degrees, so now this was an angle of theta that was in quadrant 1. When theta is in quadrant 2, so what kind of angle is that? Well, angles that are somewhere between 90 degrees and 180. Well, angles that are there have x sides that are negative, but the y side, the opposite side, is positive. So you will have a positive y over a r, which makes it positive. You will have a minus x over r, which makes it negative. And you will have a positive y over a minus x, which makes tangent negative. So the only thing that's positive here is sine. I want you to continue that investigation and complete quadrants 3 and 4 to see what each ratio is, positive or negative. Okay, as you completed it, you would have seen something like this. And again, we don't want to memorize this, right? So in quadrant 3, you can see that because of the lengths of sides of x and y both being negative, the only thing that's positive there is tangent, because we get a negative y and negative x. In quadrant 4, the only thing that was positive was cosine. All right? When you continue on, these aren't things that you have to memorize. They just make sense, right? So sine and cosine, right? Again, things that you don't want to memorize, right? So what does this really give us? It really gives us the cast rule, because when you start taking sine and cosine and tangent and obviously the reciprocals, um, you'll notice in your calculator you start getting positive and negative values. And that we learned in Math 20 was because of the fact that our sides, x, y, and r, become positive or negative, or x and y do anyway. All right? So you can memorize that, or you can remember it, or you can just think about why it happens, and that's because of positive and negative x and y, right? So we're going to use that a lot. So now, if I go to this, it said determine without technology. So don't put this in your calculator, whether they're positive or negative. So you're really just using the add sugar to coffee. And this is not something memorized, but you do have to know what they look like. 280 degrees, well, I know that that's in quadrant 4. And that's definitely going to be where cosine's positive, so sine would definitely be negative. 7 pi over 6, well, where's that? Well, this is 0, that's pi. And so it's just 1/6 more, right? It's 1/6 past pi. So that's in quadrant 3. Well, looking up there, that's positive tangent. So this is definitely positive. 10 pi over 3. Where is that? Right? Well, we should maybe think about 10 pi over 3 a little bit. So I'm going to subtract 2 pi, which is 6/3, right? And I end up with 4 pi over 3. So where's 4 pi over 3? Well, that's 1/3, right? That's 1/3 more, right? So that's in quadrant 3. That's 1/3 more than pi. So that's in quadrant 3. Well, cosine is definitely negative there. Okay, now we're dealing with cosecant of 225. Well, we probably like degrees better. What's minus 225 degrees? Well, minus 90, minus 180, and another 45 degrees. There's minus 225 degrees. It's 45 degrees into quadrant 2, and that's definitely a quadrant. Well, what is cosecant? Cosecant is 1 over the sine of minus 225. So in that quadrant, sine is positive, so that makes this positive. Cotangent of 13 pi over 6. 13 pi over 6. I actually like that one, because if you think of minus 13 pi over 6, if you add 2 pi to get rid of that big, which is 12/6, all you end up with is minus pi over 6, right? And so, oh, that's easy. This is just pi over 6 down into here. So that's the angle, that's the angle pi over 6 into quadrant 4. Well, that's tangent, and tangent's not positive there, so this will definitely be negative, right? That's definitely negative. I don't know if I put a, well, I did put a sign. That's positive. That was negative and positive and negative. And lastly, secant. A secant of 1,000 degrees. 1,000 degrees. Well, that's 360. This is 720. It might even be better for you to subtract that off. So if you take 1,000 degrees and you subtract 720, what are you left with? Well, you're left with 280 degrees. Oh, well, we already did that one. We simply come around just past 270 degrees, right? So there's 280 degrees. It's in quadrant 4. Secant is the reciprocal of cosine, 1 over cosine of 1,000 degrees. And therefore, you are definitely going to be positive in that quadrant, okay? The other thing that you want to be able to deal with is, well, how do I use my calculator in radian mode or degree mode with these reciprocal functions, okay? Well, you need to be careful that you have it in the right mode. If somebody asks you for the sine of 280 degrees, you should get these values. So just check with your calculator and see if you can work with it, and ask me in class if you're having troubles with that. when you have things like reciprocals, there is no button for reciprocals. And don't try and use that inverse button because that's used to find angles. But cosecant is done by 1 over sine of minus 225. So you should have got 1.4142. And obviously cotangent would be 1 over tangent, and secant of 1,000 would be 1 over the cosine of 1,000. Okay? The other thing I do want you to do is to be careful. When somebody says, hey, look at question H. When somebody says, yo, what's sine of 280? Notice that's different than E or G. I don't have a degree symbol. So this was just another shout out. Oh, remember that if there is no degree symbol, it is radians. So you need to be careful that just because it's a big number and looks like a whole number, it's not necessarily in degrees. Okay, it isn't degrees. Okay, that is radians. So the answer there would be minus 0.3878 because you needed to have it in radians. Okay, I'm just squeezing in something, and you need to put it on a scrap piece of paper or something. On the next slide, it talks about putting things in terms of reference angles, and I just wanted to review it in terms of degrees before they do it in the next one. So back in Math 20, if I said, hey, what's the sine of 307, I want to put reference angles and the cast rule together. So express sine of 307 in terms of a reference angle. In other words, well, when you get that decimal and you calculate, why do you get it? Well, sine of 307, if I draw 307 degrees, that has a reference angle of 53 degrees. I'm assuming you guys can handle that. So the sine of 307 is equal to the sine of 53 degrees, except for one thing. It is negative. It is negative sine of 53. And that's all I want. I don't really want the decimal. I just want you to express it in terms of the reference angle. And we are using our cast rule, or add sugar to coffee, right? So the cosine of minus 217, minus 217 is into quadrant 2, and it has a reference angle of, well, 180. So that's going to be a total of 37 degrees into that quadrant. So cosine's not positive there, so this is going to be minus cosine of 37 degrees. And reference angles are never negative, okay? So it would be minus cosine of 37. And lastly, what about a radian angle? Well, if I'm at 9 pi over 7, 9 pi over 7 is, well, this is pi, and so that would be 2/7 more than pi. Therefore, this would be positive tangent of 2 pi over 7 if I expressed it in terms of a reference angle, right? Carrying on to, you can follow that procedure, and it's kind of review what we did just in this previous question. So now if you rewrite these in terms of their reference angle, right, we're doing the same thing we just did, just a little bit messier because they're radians and they're kind of ugly numbers. So what is 7 pi over 4? Again, we're using the cast rule, right? So 7 pi over 4 goes all the way around, but it's not quite 2 pi. In fact, if you think about it, 2 pi minus 7 pi over 4, there's pi over 4 in quadrant 4. That's the reference angle. So this is equal to positive, because it's in quadrant 4 and it's cosine, positive cosine of pi over 4, right? Expressing in terms of its acute angle. 100 degrees, minus 100 degrees. Well, that takes us into quadrant 3, but there's an 80-degree reference angle there, and tangent's positive there, so this would be equal to, we want the same trig function, so we don't want tangent. This would be equal to positive cotangent of 80 degrees. And lastly, 11 pi over 2. Wow, where does that go? Well, 11 pi over 2 is, we draw that out, and where does that end? Where does that end? It ends up, right? So 11 pi over 2, there's so many different ways to explain how it gets there, but one way would be say, well, pi over 2 is 90 degrees, so there'd really be 1190. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it ends up right here. It's right on the axis. That's 11 pi over 2. Well, this is sine, and sine is not positive in either of those quadrants, so this would be minus the sine of the reference angle from either side is pi over 2. So that would be minus sine of pi over 2. Okay? In the next question, again, you can pause and complete this. You've done questions like this in Math 20, so I'm going to go fairly quickly through this, and they want you to take a point and find the exact value of trig ratios. You know how to do this from Math 20, so I'm just going to scroll through, but you can pause and then come back and look at it, right? So if your angle of rotation stops at that point, you need to find the exact length of the radius. So when you find the exact length of the radius, it turns out to be the square root of 289, which is 17. And there are all my primary and reciprocal trig ratios. Okay, all right. And lastly, in question number 6, you're asked to, from a trig ratio, find the exact value of the other of some other trig ratios. Okay. Well, the first thing, based on the conditions, they tell you that cotangent is root 5 over 2. Okay. Well, cotangent is root 5 over 2. So the first thing I might think about, and it depends, and also sine is negative, right? So sine A is negative. Well, that's cool. So we've got some angle A that's somewhere, that's the ratio. Now don't forget the cotangent is the reciprocal of tangent. And tangent, right, tangent of A, if it was, would be all about y over x. So this is actually x over y, okay? Not opposite over adjacent, but adjacent over opposite, okay? But what quadrant is it in? Well, sine is negative in these two quadrants down here. So it could be in this quadrant, but it says that in this case cotangent's positive. So the only quadrant this could possibly be in is quadrant 3, because that's the only place where tangent's positive and sine is negative. So I'll put that there, and therefore my sides are going to be x, which is minus root 5, minus root 5, silly, minus root 5, and the y side is minus 2. I need to calculate the value of, sorry, I guess I better follow and finish this off. So it must terminate in quadrant number 3. So just a little reminder, we're drawing the diagram for B. This is the angle A that they're talking about. When we talk about the reference angle, that's this angle right here. So my reference angle's there. Angle A goes all the way around. This is my x side, this is my y side, and there's my r that I'm looking for. And now we complete that in number C, and r ends up being equal to 3. So when I go to find those other trig ratios, they end up being equal to, cosecant A is minus 2 over 3, and secant of A is minus 3 over root 5. Some textbooks, and I don't know what ours is going to do, but some of them won't leave it like this, and that's just because they rationalize and they multiply top and bottom by root 5. So you might have answers in the back that look more like this, minus 3 root 5 over 5. They are identical, but one has a rational denominator. All right, we will see you tomorrow.